Hello, and welcome to the Equinix Developers YouTube channel, Twitch, and Periscope. My name is David Mackay. You may know me better as Rockwood. Today is Fortress Meets, and today we are meeting Bofied, a modern network boot server. And to guide us today through this project is its creator, Felix Pointinger. Hi, Felix. How are you today?
Nice. How about you?
I'm very well, thank you. It is well, it's a terrible day in Scotland. It is cloudy. It was raining all night, and it's very windy. How are things for you? I believe you're in Germany, right?
Yeah, Stuttgart. Beautiful sun, beautiful summer today. Actually, not a single cloud. Yeah.
We had lovely weather last week. I don't know what went wrong yesterday, but hopefully it gets better again soon. So can you just do a little bit of a favor, please, Felix, just to kind of introduce yourselves, tell us a little bit about you, what you're working on, and then we'll talk about Bofied from there.
Sure. So I'm Felix, probably better known as @PointFX on Twitter and GitHub. Yeah, I like to write open source in my free time, and yeah, currently uni student, so don't have too much time to spend on it, but yeah.
Yeah, and we had a little chat just before we went live, and you were saying that this is your first semester at university, and you've never been. It's been entirely virtual.
Yeah, it's the third semester, but yeah, yeah, exactly. So yeah, started January. Oh, which was it? March 2020. So yeah.
Nice. All right, we got comments coming in, so I'll pop a few of those on. More German people enjoying the lovely weather. Damn you, Kevin. All right, so you want to kind of give us the high-level overview of Bofied and what it is, please?
Sure. So Bofied is a network boot server. It has pretty much everything you need to network boot to PXE boot, including a TFTP server, a proxy DHCP server, etc. So it's a fully integrated solution in a way. And yeah, basically it makes it very easy to just network boot a node. For example, to, I don't know, quickly test out a distribution or run Kubernetes on it. Yeah, that's basically it. And probably what sets it apart a bit from other solutions is, well, it's modern in a way. TFTP, D, etc. are pretty old projects at this time, written in C, etc. So yeah, that's pretty new. It's written in Go. And plus, it's got a nice user interface. It's got a gPC API and a WebDev API, so it's easier to manage. It's also got a web front end, so even probably not that technical users can still use it. So yeah, that's the project.
Yeah, I think it was you posted a demo on Twitter. I think it was a couple of weeks ago, and
exactly.
You were showing the user interface and the web dev support, and I was just like, why doesn't this exist already? Why is it taking till now for someone to make these awkward operational tasks easier? So I think, yeah, it's nice to see that fresh approach to it. But I do have to ask, like, you're a young student, and you decided one day, I want to go play with bare metal and TFTP and PXE. Like, how did that come around?
Well, it's kind of it's a weird thing. I grew up in the countryside, so I had a very bad internet connection. So many times using, say, a public cloud service, for example, was harder because just because of internet speed. Like if you have to push a 1 gigabyte Docker image and it takes like 30 minutes or something to push it, it's getting a bit prohibitive. So I had to like kind of run my own infrastructure, but I still wanted to use modern cloud stuff. For example, Scaffold. I really like to develop on a Kubernetes cluster, and I somehow had to have a easier way to do that. So yeah, just got myself some old laptops and set them to PXE boot, and yeah, I initially used, of course, like TFTPD and the default stack for it. But it turns out it was very hard to manage, and especially when I moved a bit to Stuttgart to uni, for example, setup just broke, and I was like, okay, I have to make this, either make some Ansible script or something that does it for me, or just rewrite it. And after I tried the first one and failed, I was like, okay, maybe it's easier to do it just from a clean slate. And yeah, because before Bofied, I developed Livask, which is like a high performance network scanner, but also intended to like basically provide inventory of local systems in a private network. So I was like, okay, that stack works really well. Why not try making a TFTP server with it? And turns out it worked. Yeah.
Damn it, TFTP, PXE, and high performance network scanners. Like, you're picking interesting space to work in, like, definitely. But I think this is a really cool space where innovation can be. All these tools are really old, right?
Yeah,
I
yeah.
could never remember how to do network scanning with, Netcat or any of these other different tools. Like, I think the things just need to be better. All right. I think that's really cool that you also said there was more need as well. You needed these tools for your certain conditions and constraints, and I think that's a really cool way to drive new paradigms as well. We have a comment from Carlos who's asking, do we have any examples of Pixie booting a Raspberry Pi and deploying Kubernetes?
Not yet. It does support ARM. I actually tested it privately on a Raspberry Pi, not today though. I mean, it's so by default it downloads iPixie for pretty much every platform that it has available, including ARM32 and ARM64. So that should just work. Yeah, I haven't tested it, or I don't have a live demo, but it works. Yes, it's tested.
Yeah, I think there's a lot of examples online as well of booting K3s on Raspberry Pis. Alex Ellis has a lot of content to do with Raspberry Pis and Kubernetes, so maybe that is worth checking out. And maybe Bofied is now going to be a nicer way to get that deployment kicked off. So for today's session, you're actually going to guide us through deploying, I believe, a device on Equinix Metal, running Bofied, and showing us Bofied on top of Equinix Metal. I'm not sure if there's anything else to it, but what I will say is feel free to show us what you want to show, and I will do my best to ask as many silly questions as possible throughout. So if you could just test your screen share, and, we'll see where we're getting here.
All right. Should be there.
We are indeed. Go for it. If you could do a few Zoom clicks in.
Oh yeah, that's probably a good idea.
I'd go one more. Just
I
know it's going to be awkward on your side, but it makes a big difference on this side.
Yeah,
that's perfect. Thank you.
All right, perfect. So what I was thinking was basically going through the getting started guide. Because we're deploying on Equinix Metal, I will have to do one more thing, which is to set up a DHCP server, but that should be pretty quick. So yeah, maybe I'll give another quick overview of the project. I've got this little demo video here. Maybe it helps to visualize a bit what the project actually does. Just hide this right here. So yeah, basically this video shows well, how one could get started. For example, over here we can see, well, we have got a web interface where we can configure both the configuration, I'll be going to that later, and the files. Plus we can select scripts, we can do all of that. And yeah, it's basically a full file manager for web dev, but I'll be showing this in more detail later. Yeah, just read them out of that. We can also get events from the network. And as you can see here, this is a laptop connected to a, well, LAN over here. And right on the right here, we can see the Bofied interface. And I'm just going to boot this device to Pixie boot. So it's going to take a little bit of time. And yeah, as soon as we select the network boot device, you will see on the right that the device shows up. Because and this works because Bofied is also a, so as you can see, it sent DHCP packets. Bofied is also a very minimal, only the very, very bare basics, a DHCP server, or to be more precise, a proxy DHCP server. So we can also get, for example, information about which nodes booted and so on. And as you can see, it now sends the relevant information, and it boots iPixie in this case. Yeah, and as you can see, in a few seconds, it will boot into netboot.xyz. I'll also be showing you how to configure custom operating systems using it, of course. And yeah, in this case, I've decided to quickly boot K3SOS, but you can, of course, choose any distribution. As a matter of fact, whenever I'm distro hopping, this is the way I go nowadays. It's much faster than downloading the ISO and burning it to a USB or something. And yeah, in a few seconds, you should see it boot. And yeah, here we go. The system has been booted. So today, I want to try basically the same thing, but on Equinix Metal, on a public cloud. And yeah, so maybe a bit of an overview again. As you can see, I tried to make the doc somewhat usable. So yeah, probably most information you'll also find in the description. But yeah, so basically, again, the features. So it can obviously network boot stuff. It is also a TFTP and HTTP server, so you don't have to set up, say, a separate Nginx server or something for that. It can do all of this. It's also got a web client with WebDev API, so you can edit the configuration file without having SSH access, just using your browser. It can also be used, especially if you combine it with Livask or something like that to also monitor network boot. So it gives a bit of an insight into what's happening on the network, which basically allows one to drop Wireshark, which is of course very, very nice. And it can also be deployed offsite. It uses OpenID Connect internally, so you can securely expose it to, say, the public internet without much problems. For example, I use it to manage my quote-unquote data center of old laptops at my parents' house, which works pretty well without having to be there all the time. So yeah, that's pretty cool. I see a question in the chat. Does it support multicast to distribute images to multiple machines at the same time without hogging the whole line? I don't think so yet. It's not my own TFTP server. I'm using a Go library. So if maybe the library does it, I haven't tested it though. Yeah, would have to test that.
Yeah, something to test another day.
Exactly. All right. Yeah. Okay. So exactly. The problem is we always hit in client data centers is network folks own the DHCP server and didn't want to allow. Yeah, that's exactly the reasons why I implemented it as a proxy DHCP server. So for me, it is the exact same situation. It's one of these German ISP provided setup boxes, which have a pretty much non-configurable DHCP server. And the nice thing about Bofied is you can just deploy it in a network that already has a DHCP server running, and it should work without any problems. It just uses proxy DHCP, so no need to change anything to the normal network configuration. It's a pretty nice feature, I think.
Yeah, nice.
All right, so let's get started. I was thinking about basically just going through the getting started guide, and let's hope that the demo gods have mercy today.
Well, if my observations of your GitHub repository over the weekend, like there's some cutting edge commits that are going to make this work, right?
Perfect. So I've already set it up here, but I'll be starting from 0 so that it's somewhat reproducible. So yeah, the first thing I'll be doing, and this is basically because we need a layer 2 network, obviously, in order to fix the boot, is set up a DHCP server. Again, it's only a proxy DHCP server. So in this specific case, I will be using DNS mask for it, but you should probably not use this, or you shouldn't have to use this if you're already in a network which has proper DHCP setup. So, well, in this case, I'll be first setting up the DNS mask server, and I'll be using a dedicated server for this. Although, of course, that's not really necessary.
Could you zoom in again?
Oh yeah, sure. I should have probably set the system scale beforehand, but yeah. So I'll be using call it Bofied demo let's call it DNS mask. And in this case, well, I've already set that up, so let's just deploy it. I'll be setting up the networking right after it has been provisioned. Probably take a little bit of time, but yeah, so we can already prepare the commands over here. Oh. Take a bit of time until it has actually been provisioned. So the first thing I'll be doing is because it requires layer 2 access, I'll be first modifying the network configuration a bit into the, I think, which one was it? Let me just check for a second. So I'll be setting up a VLAN for it, a new one, of course, in this case, and then be setting up VLAN support on Debian as well. I think I have to do something there as well. So
have you already? No, you're creating the VLAN now. Oh, no, you've got one, right?
Okay. Yeah, I've already got one. Although, now that I think about it, I'd probably just turn the other host off here. Otherwise, the two DHCP servers will fight one another, which is, of course, not the intention. Yeah, of course. So I'll turn this one off, and I'll turn this one off. There we go. It's still provisioning. It'll probably take a bit of time. But yeah, it's a good idea. Otherwise, I would have set up another VLAN, but of course, we can just reuse the one that already exists.
Yeah, that makes sense.
Yeah.
So this will probably take, I guess, up to about 5 minutes before that's going to be provisioned and ready to go, or maybe not. Just rebooting already.
Perfect. So I'll be setting up another server right now while the other one is provisioning. This one we will just be using as the host that runs Bofied. But yeah. So again, this would also be possible to do on one system. I'll just separate them, so it's a bit easier maybe to understand. I hope let's just double check that I actually selected the correct region. Yeah, perfect. So here we go. And we're also going to install Debian. Of course, it all runs in Docker, so there's, of course, no distro requirement.
Yeah, so it doesn't really matter if it's Debian. It doesn't matter if it's Ubuntu. It's just Bofied is just a container image that's going to, I'm assuming, uses the host networking.
Yeah, exactly. It requires access to raw sockets or to the lower ports. So yeah, exactly.
Yeah.
So Bofied demo dash, I just call it, well, Bofied probably a bit, let's call it provisioner. It's a bit more sane probably. And yeah, there we go. So as you can see, we've now also got the server. Oh, and I see, does it have a stateless mode, like booting a Docker container, or like booting a Docker container pointing to an URL in the config? Yes, it does actually have that. You can select a so-called starter, which currently is basically just, right, where are we? Currently, this just downloads netboot.xyz or the upstream iPXE stuff, but you can provide any link there, and you can just use it. You can even like put, say, for example, if you want to self-host, say, the Debian repositories or something on it, you could also do that. It's very flexible, and everything is configurable using environment variables. It's a 12-factor app, so it should be pretty easy to deploy. And yeah, the only state it really has is for caching and so on, and because you want to access it using WebDAV. Yeah.
Okay. Can we just take a moment to just make sure I understand kind of what's happening? And also, if you could zoom in on that term.
Of course.
But let's go back to the Equinix portal just now.
Sure.
So we've got a couple of devices spun up, and I just want to make sure I haven't missed anything and I know what's happening. The Bofied demo DNS mask. Can you just quickly tell us what that's doing again?
Yeah, perfect. So the DNS mask node here, it will be serving a DHCP server on the VLAN, so that because Bofied is only a proxy DHCP server, it still requires a proper DHCP server to be set up at some point. So basically, this node will be providing the DHCP server for the VLAN in this case.
Okay, and are we going to do that manually, or have you injected some user data into that to do any configuration?
I'm actually going to do it manually this time around. It shouldn't be too long, I hope.
You're very brave. So now you're attaching it to the VLAN.
Exactly. So now I'm switching to layer 2 mode because, well, DHCP requires it. So that will probably take a little bit of time.
It'll just take a few seconds. And then, so this is just configuring the top of rack switches where the device is, but we're still going to have to SSH onto that device and configure and add the new interface, which I'm assuming you're about to do in your terminal.
Exactly.
Okay.
Exactly. So I prepared, again, we were going to switch to hybrid bonded mode, and we have to do one more thing to actually support VLAN, it turns out, which is loading some kernel modules, which, well, I'll be doing in a second, although I'm not sure. I might probably have to restart the device, right, before I can actually use the layer 2 network, or is that already working?
No, you don't have to restart. You'll be okay. No.
All right, so...
especially because you're in hybrid bonded, so all you need to do is kind of restart the one interface, you'll be okay.
Okay, perfect. So yeah, in that case, I'll just be loading the relevant kernel modules. It's already Equinix docs and I guess I created. So yeah, let's just check, but I think it should have worked. Yeah, there we go. It's the module is loaded. And yeah, I'll just be adding it to the permanent config. And this is basically just copy and pasting a whole bunch of commands, so it's not too interesting. Turns out it actually copy and pasted everything. Well, it's so this is going to be the VLAN ID, and we can see that in down here. In this case, it's 1000, but it's of course also possible to create multiple. And in this case, if I remember correctly, it would be yeah, the same VLAN ID. So in my case, again, it's going to be 1000. This just creates the interface.
All these docs are available for people. You don't have to see what's being copy and pasted. The link is on the screen. You can do this your own time.
Exactly. It's basically just copy and pasting a few commands. And yeah, we'll also be starting the device. Now, oh, actually, it's 1000. Here we go. So yeah, this is the setup for that device. We can also do this, of course, using a etc network interfaces or some other system. Yeah, so that should basically work. And if we check the interface, we can see, yeah, so there we go. And I'll be using this IPv4 subnet, but of course there's no hard requirement on it. One just can't use this one because this is what Equinix is using internally, obviously, but yeah.
Yeah, we don't like network collisions.
Of course. So yeah, this should pretty much be everything we have to do over here. Now I'll be installing DNS mask. Again, this is only required if one doesn't already have a DHCP server running. And apt install -y DNS mask. And yeah, so I already created a what is it? I already created a DNS mask config, which is also available in the gist, of course. But yeah, I'll just be basically copying and pasting it into here. And if I remember correctly, this should already have the correct address, right? In this case, I will. We have to do one more thing, which is also set up a gateway, because otherwise we would already be able to use use Bofied like this, but we wouldn't be able to, since the devices will be in layer 2 mode, when they PXE boot, they wouldn't be able to have public internet access. So it's a little bit of a workaround. I'm just going to set up this node as a gateway as well. So I'll be restarting DNS mask over here, and if we check the logs, yeah, it works. All right, and
we'll include a link to the guest with the instructions in the show notes. So if you check back later, you'll have access to that.
But exactly, perfect. So as you can see, it's already running on port 67. So yeah, perfect. Now again, the next thing I'm going to do is just a little bit of a trick to basically get the routing to work. But yeah, so here we go. It's just
good old IP tables.
Yeah, exactly. All right, so now we should have a DHCP server running on our VLAN, and in the meantime, I hope that the other server has been provisioned. Oh, not yet. No.
Oh, there it goes.
There we go. Perfect. And I just SSH into this node as well. And this node will be the node that will actually run the Bofied in this case. Now, I will also be switching this to layer 2 bonded mode, of course, as it has to access the same VLAN as the DNS server, and sorry, DHCP server. So I'll be doing this in a second. Here we go. And we'll just have to run through the same thing again, although this time around without with a different IP address, of course. I'll be using .2, I think. So yeah, I just basically copy and paste these commands again. It seems as though the escape sequences aren't really working.
Yeah, that's weird.
Oh, and then it seems as though I have lost connection to that. Oh, well, of course, I just changed the network configuration. That might play into the SSH command. I just, where are we? What is the IP address again?
Did you lose connection to the machine?
Yeah, doing it's currently locked.
Oh, you had to load the modules, right?
Yeah, probably. I'll just, well, now it doesn't have an IP address anymore. Did I accidentally switch to the wrong network type? Is this in layer 2 bonded mode? It's hybrid. Oh, yeah. Oh, that was my mistake.
Yeah.
I meant to switch away. So what I just did, switching to pure layer 2 mode, that will be necessary for the actual PXE booting nodes, not for the node which will be running Bofied, of course.
Yeah, so you still want to keep this in hybrid mode.
Exactly. All right.
So that should just magically come back, hopefully, once the switch is configured correctly.
Yeah.
I guess on this machine, you're just going to be installing Docker, pulling the container, and then in a Docker container run, right?
Exactly. So as you can see, actually it worked without interruption. Oh, that's nice. So we're back.
Oh yeah, I mean, the OS probably has no idea anything happened because it just stopped sending the packets. So.
Exactly. So the first step, I'll be installing Docker, but we will have to do the same network config we just did on the other device as well over here. Again, it has to be in the VLAN, and it has to know it is in the VLAN as well. So yeah, we'll just go ahead and install Docker over here. Let's hope the Debian provided version isn't too old. And
that's
next
business.
Exactly. So I'll just copy and paste the commands from history this time around. Yeah, here we go. I'll just set up the modules again. I think I already did that, but let's double check. Yeah, there we go. Q module is loaded, and we'll just be adding the VLAN device again. Here we go. And of course, this time around with a different IP address to prevent collision. So I'll be using .2 over here. Yeah, the I is missing. Here we go. And we will set the device up. And I think we should be good to go now. If we check the network config, here we go. Got .2, and just to check if we can actually ping the device, or if the VLAN works, let's try if we can reach it.
Dun, dun, dun.
And well, there we go.
There you go. Nice.
Perfect. So the VLAN is now set up for the 2 nodes, and let's get started with the actual Bofied installation. So I've got a few commands here. For example, one of the things that people ran into immediately was not having the ports open, because, for example, on Fedora Linux by default, DNS mask already runs in the background on that port. So be careful that the ports are actually open. Although, of course, Bofied will also warn if they aren't. And yeah, so the next step is to get the IP address which Bofied should advertise. So because Bofied is, amongst other things, a DHCP server, it needs to know its own IP address. or to be more precise, it needs to know on which IP address it should bind to, for example. So in order to do this, it's also described, of course, in the documentation. We have to get the IP we just assigned. Of course, we just assigned it manually, but this would be, so for example, if you would be on another network, we would have to choose the IP here. And yeah, that's pretty much all the configuration one actually needs for Bofied to work. So there's nothing else. I will be setting up OpenID Connect as well, so that we can securely connect to the web interface. But yeah, so in terms of the system config, all Bofied actually needs to know is this IP address, and that's everything.
Does that support IPv6?
I'm not sure yet. I haven't actually tested it on IPv6. Probably it should. I don't have anything IPv4 specific in it, so yeah.
So it may just work.
It may just work
for someone, yeah.
Exactly.
We also have a question from the Fireflash here. Does this also work with Podman?
Yeah, exactly. I actually mentioned it in the documentation as well. It's also tested with Podman. I myself also use Podman on Fedora over here, so yeah, it's tested. It works.
Nice.
So yeah, let's get started. I'm going to use Auth0. In my case, I already set up a OpenID Connect client secret or client ID actually. So let's just.
So this is to protect the access to the user interface.
Yeah, exactly. So because one of the big things for me at least was I wanted to have something that I could administer using basically my phone, and I didn't want to have to SSH into anything or more precise, to give anyone SSH access to the server that runs Bofied, because, well, I mean, it's in a private VLAN and it's probably not the best idea to give anyone access to it. Because I've set up OpenID Connect, and this also makes it possible to use pretty much any OIDC provider out there. It doesn't have to be Auth0. One could, for example, use, say, the company's G Suite login or something. It's pretty simple to use. And if we put it behind HTTPS, it will also be, of course, zero trust. So that's pretty nice, just in terms of security. So yeah. So in this case, I will be copying and pasting the client ID over here. It doesn't require the client secret. I'm using a OIDC library for Go over here, so it's really simple. So yeah, in this case, well, actually, it turns out I have to edit it. So we'll be using this IP address. So this is the backend advertised IP, and again, documentation for these environment variables are all available in the GitHub repository. Yep. And in addition, we're going to require the client ID, of course. And yeah, I think the defaults are actually already correct in my case. This is my OIDC issue, so that should basically just work. And let's see if it can pull the image.
Should work is my favorite phase.
True. So let's check this if it actually is working. And yeah, as you can see, it's already starting. If the ports wouldn't be available or something, it would of course crash over here. But since we checked it before, it should now be working. And if we just quickly check if the ports are actually bound, we can see 69 and 67 are bound for DHCP. In this case, it's DHCP and sorry, TFTP and proxy DHCP. So yeah, that's all working.
Is an alternative?
Oh yeah, it's the so Netstat is deprecated at least in Debian since the IP route 2 tools came out. So SS is it's basically the exact same command, but it comes from the IP route 2 package. So
all right. I had no idea. Today I learned. Nice.
Yeah, it's pretty nice. So as you can see over here, wait, I just entered the same command. I just wanted to check TCP as well. But we can see we're already running on port 50,000, etc. So yeah, one thing you would probably, or in a production setup, you would of course set this up to use something like Caddy or something as a reverse proxy, because right now it's running using just plain HTTP, which already works, but is a bit insecure. So what I'll be doing now is I'll be forwarding the ports, of course, to be a bit more safe. But yeah, and the ports, I mean, we only need it for the interface, I think. This localhost. Of course, this again wouldn't be required for a production setup, and I can show you if anyone is interested to how to set up Caddy as well here. So yeah, and if I remember correctly, it is 6 in the end. So one of them is the gRPC API, or basically all APIs. They are all behind the same HTTP server, and the other one is just the web interface. Oh, sorry, it's the 2 APIs. Let me actually double check. I'm sorry. Actually, you only need the last one. The first one is not required. The first one is...
You're just setting up an SSH tunnel from your local machine to the Bofied server in Equinix Metal, so you can browse to it locally, right?
Exactly. So that the alternative to this would be, of course, to set up HTTPS, which I always do when I publicly, but I guess setting up DNS is out of scope. So yeah. But I can show you, for example, the demo I used earlier runs on HTTPS. But yeah, exactly. So so here we go. And the next step basically is to connect the front end, I think. But let's quickly jump back into the documentation. Maybe a little bit of a note. So if for some reason one can't run Docker, I also supply static binaries for the entire thing. So it's basically the Docker image contains nothing but the static binaries. So if for some reason one wants to use just a config file in the systemd service, that is of course also possible. There's no need to use Docker. Yeah, and the next step over here is to theoretically set up the firewall, although if I remember correctly, none is running right now, so that would actually not be required. Yeah, so, and as you can check again, it should be running now. So we can now connect the front end to it, and there's a handy link over here, which will launch the Bofied PWA. In this case, it is still configured to use the demo from earlier, but you're welcome. So they asked about the binaries. Yeah, I also like to sometimes just be able to download a binary instead of using a Docker image. I don't know. Sometimes it's just a bit easier. Okay, so over here we will now be providing the port number for it, and we are using plain HTTP. Again, of course, in production one would always use HTTPS here, but it should work too.
Can you zoom in on this page as well?
Of course.
So this is just a progressive web app. You're hosting it on GitHub. Anyone can use this to connect as long as their gRPC server is potentially available online, or exactly. I guess they could just run this UI on their own network, right?
Yeah, exactly. So the entire front end is it's of course also open source, and if one wants to host it, they can do them themselves. And with every release, I also publish it as a TARGZ archive if one wants to use it. It's just a static PWA. It's written in Go as well. It's built in WebAssembly. So it's just a WebAssembly binary, an index HTML, and some glue JavaScript code for starting the WebAssembly binary. It's very easy to self-host. However, it shouldn't be required for most users anyways, because the web app, it just runs publicly and it allows you to configure your own backend URL. That makes it very easy, I think, to get started because, for example, you can just click on the little install app button on the top right-hand corner over here. And as you can see, it now also runs as a proper app. So for someone who likes to use, say, for example, normally native apps, or someone who likes to, for example, like myself, manage their TFTP server from their phone, this is, of course, pretty useful. And it also works. And it also works offline. So the first time one opens up the app, it registers the service worker in the background. So, for example, if this is if one wants to run the front end on a completely air-gapped device or something, this would also work. Yeah. So with that out of the way, let's try and connect to it. I'll probably have to authorize first. No, I don't actually think so. I think it just worked the first time. I like to see that, of course. and as you can see, it's now connected to the front end and sorry, to the back end. And let me just double check that we're actually using the correct endpoint. That sounds a little bit too good to be true. Let's just check if I'm not running it locally. No, it seems to work. All right, perfect. In that case,
confused by that.
Yeah, most of the times I mess something up with either the open connect reconnection or redirect URLs and so on. But turns out it worked just the first time. And we can also now play a bit around with the interface. So on the left hand, you can see the configuration file. One of the things that I found to be very annoying with traditional solutions to TFTP servers is, okay, how exactly does one say if this or that architecture wants to boot? How can one provide a different configuration file? Or in my case, for example, how can one boot using the same TFTP server different architectures? So one of the way that Bofied solves it is it gives you a complete scripting language for it. So this is done internally using Yaegi, the Go interpreter, but it's very simple even if you don't know how to use Go. So basically, the configuration works like this. It's a config file, and we can also take a look at the config file in a second. But what it allows one to do is it allows one to basically say, okay, if it's a function, it exports a function called file name, and it takes in an IP address, a MAC address, an architecture, and an integer. And those values will be supplied by Bofied. And in here, and it returns a singular string. And that string is basically whatever binary it should boot, or whatever binary it should tell the client to boot. And as you can see over here, by default, on the first boot, it downloads a distribution of iPXE of mine. I just publish these using GitHub Actions every once in a week. And these are basically just hard-coded to always chain load /config.iPXE, so that one doesn't have to recompile the iPXE binary every time they want to change the script, which is, of course, takes a long time. So this is what it uses internally. However, you can change this. So if you just go down to the reference, you can just provide an arbitrary starter URL and replace it. So there's no need to use these predefined binaries, of course. And yeah, so as you can see over here, for example, if we get in the x86 and a machine with a BIOS on it and the x86 architecture, it will return the relevant iPXE file. And as someone asked earlier with the Raspberry Pi setup, for example, this is the part that makes it work. And this also works out of the box. So yeah, it just uses the ARM64 distribution of iPXE and with ARM64 version, and that is tested and it works. So this is a very cool way, I think, to edit the config file. It also has got basic syntax validation, because one of the cool things is, because the app is written, the frontend is also written in Go, I could just use the Go compiler APIs to check the config script, which is, of course, a pretty nice thing about WebAssembly. But yeah, and by default, you can also, yeah, one more thing probably, there's also a configure function. Most of the times you won't have to touch this, but if you want to use anything from the Go ICD lib, for example, if you want to make a HTTP request to return this API, which is totally possible, you can just flip this one switch over here to true, and you will be able to run anything inside of the config script. So for example, if one wants to have like an own microservice that sends back the correct boot file, some external system or something, you could just do a HTTP request here to set service and return the relevant string. And it's also possible to log in here, and the logs will show up in the events panel. So it's pretty advanced. And if one doesn't want to have this because of security reasons, well, of course, it's disabled by default. And you can also provide a switch to Bofied to completely disable anything, any remote or any potential remote code execution problems. So it should be fairly secure in terms of that. So that is the config script. Again, this is the default. You can, of course, do anything over here. And on the right-hand side, we've got the file manager. And what this is it's basically a client for the WebDev API. So WebDev is, as some of you may know, a web protocol for file management. And so yeah, and basically what this allows us to do is to manage the files which are on the TFTP and the HTTP servers. And there are multiple ways to do this. The probably most obvious way is to just do it using web interface. For example, if we want to download, if you want to upload anything, we can just select it over here and just upload it straight to the TFTP server. So there's no need to use SSH again into the server. And it is also possible to edit files over here. So for example, if we want to edit the iPXE config script, which is what will be chain loaded in the first boot, we can just do this also right away from the browser. So there's no need to access it using any external software. However, I do, of course, understand if one wants to do so. So over here is a little button called Mount Directory, and you can just basically copy and paste this. And if you're on Linux, you can just open up your file manager, click on Other Locations, paste the URL over here, and it will ask us for username and password. These are basically just temporary credentials we can use for that. And there we go. It's now mounted to our local system. And if we wanted to, for example, use VS Code to edit the config script, we can just open it up over here. And well, over here, we've got it locally. And whenever we save it, it will be instantly synced to the server. And yeah, so it's pretty flexible in terms of its configuration. And because someone asked earlier about the ability to run it stateless, one way, for example, would also be to set instead of using the starter URL to download it, you could also just mount that volume. The entire configuration is done inside of a singular folder server side, so it's very easy to use it like that. Yeah, so
would it be possible to syndicate that to like S3 compatible storage? So like if I ever did destroy the machine and spun it back up, I could just resync and pull that stuff down?
Sure, that would be possible. It will also, because it will, of course, so in this case, for example, it's just using a Docker volume, but I mean, that Docker volume could be backed up by anything, including S3, for example. So yeah.
Yeah, I wonder if the WebDAV could be swapped out for like for S3.
Yeah, I was thinking about this as well, but S3 seems to have so I wanted to have this workflow where I could basically just open up the file manager and just mount it. And because S3 is, I mean, it's not technically a proprietary protocol because it's, I mean, everyone has got a client for it. I wanted to use something that is an actual web protocol. So yeah, the thing is, Nextcloud uses WebDev as well, and there is some overlap in usage here.
Yeah, plus there are WebDev clients for your mobile phone too. So if you really want to make changes on the fly, that would definitely be possible.
Sure.
We got a question from Kevin asking if one could use the CMDB to decide which operating. Yeah, so I think what he's saying there is you could use your config, which is written in Go, to make an HTTP request to a database and decide which operating system should be booted on each device.
Yeah, exactly. That would work.
Very cool. I like it.
Okay, so that's some of the interface. Of course, if you need any help or something, there's also documentation for it. And maybe one last thing, which will be the focus of the rest, I guess, is the events panel over here. So the events panel is hooked up to a gRPC API, or potentially, actually, technically speaking, a gRPC web API. And one could also use this gRPC web API externally. For example, if one wants to, say, monitor what devices are booting, of course, they can do it with the web frontend, but they can also just access the API directly. There's a link to the relevant .proto files in the project description. And yeah, so this will basically allow us to have an insight into what's happening on the network while it's booting. And it has turned out to be very, very useful when debugging network issues as well. That's a nice side effect of it. All right, so now that I've given a short overview over the interface, I was thinking of now actually booting something. And yeah, so that's also fairly simple, actually. Now that we've set up the VLAN, all we have to do is to use any node. I already have one over here. I will swiftly delete this one, though, which it seems to be hanging. I will just be creating another one. So this would basically be the workflow that one would do if they wanted to now PXE boot an actual device. So now that Bofied is set up, we can configure what operating system to use using the config.ipxe file or anything else. The default just runs, sets up DHCP and chain loads netboot.xyz. But for example, if one wanted to say boot Debian or boot some Kubernetes distribution, they could just put the files for the relevant, say the kernel, for example, into this directory, and then just configure the config.ipxe file to their liking. So yeah, this is a very flexible system. And it's also possible, maybe if one hasn't had that much experience using ipxe, it's also possible to, for example, query like the processor type in here or query the relevant network interfaces. It's a full scripting language, so there are no limits to what one can do over here. So you're not completely limited to just using this config file. You can also use ipxe for it. And yeah, so the next step again is to actually create a server that should boot. I'll be using on Frankfurt again. In this case, we will be using custom ipxe. I think this is actually not really required because it will be PXE booting, but yeah. So let's see what happens if I keep it empty. Maybe it will complain. We'll see. Otherwise, I'll just put the actual start script in there. And yeah, I'll just be calling this node 2 because I already have a server named node 1. And let's try and go ahead. Okay, can't deploy servers. Well, of course, it makes a lot of sense to block that action. In that case, I will be just using again, and yeah, it's probably a good way also to actually demo the config system. So, for example, in this case, I want to create a new ipxe script, which just basically chain loads ipxe itself. And you can also do this using Bofied. For example, over here, you can create a new file. I'll be calling this one boot.ipxe. And over here, what I want to do is it's very simple, but it will just be auto boot. And what auto boot will do, it will just do PXE boot, but using ipxe itself. It's kind of a bit of a hack, but it works really well. And now we want to get the URL for it, and we can just click on the little share icon over here. And because we're now inside of the VLAN, we can also just flip a switch over here. It says I'm using advertised IP, and this will query the IP address of the server and give the correct link over here. So in our case, we will be using this link over here, which should work. And we can just provide this as the start URL. Let me just save the script. Oh, I've already done that. And I'll flip this switch so that in case anything goes wrong, we can just reboot the server and try again. And yeah, there we go. Let's see if it works. Probably take a little bit of time. And to debug this, a very handy tool is the out-of-band console. So I will be SSHing into that. So this is basically, so if one were to, for example, boot a server, like say, for example, in their local network, it's very useful to have a screen to access in some case. And a nice thing about this platform, about Equinix, is that we have got this out-of-band console, which will allow us to do the exact same thing by just SSHing over here. And never mind this one. This is a client configuration problem on my part. And yeah, here we go. It'll probably take a little bit of time for it to actually boot up. After all, it's still being provisioned. Just check. Yeah, and there we go.
Yep.
And requesting system reboot. And here we go. It's device. And let's just split the screen. I hope it's still big enough for everyone to see. Of course, Bofied is responsive, so technically speaking, it should be able to stay here. And yeah, there we go. So if everything goes well, what we should be seeing shortly is the device PXE booting. Will take a little bit of time, but yeah.
Yeah, bare metal reboot times are not particularly known for being quick. So.
Yeah, definitely.
Although this, I think you picked the SC3 small, so this one will be a little bit quicker than one of the larger instances, which has a whole bunch of post checks to do.
Yeah, exactly. So yeah, this will take a little bit of time. In the meantime, maybe I will just open up the logs on the DNS mask server. This is just to of course, you would probably not have to do this most of the time. I'll just double check. It's var log tail-f/var log DNS log. So I just see if it actually is doing the requests properly. Of course, it should be doing them, but in case it doesn't, a bit of debugging might be a bit useful. So here we can see it starting to PXE boot.
So what's actually happening here is this device is going to boot up PXE boot to Bofied, which is going to proxy the DHCP request to Equinix Metal, assign an IP address to the machine, and boot it from the auto boot. So I'm not sure which image is going to boot on this device, but
yeah. So in this case, we're just booting a netboot.xyz, which allows us to select any operating system interactively. But yeah.
Yep. Okay, so we're just using netboot. Which is going to give us any operating system that they support, so you can just throw Debian and Ubuntu CentOS on it, and it's just going to install the thing. That's it.
Exactly. And the nice thing is, IPXE allows one to specify kernel parameters, of course. So in case someone wanted to, for example, boot Debian, they could also provide, for a really traditional setup, something like a pre-seed file, etc. Yep. So that would allow it to be completely unsupervised. So yeah. 1 second. I think I forgot to set it to the layer 2 VLAN. It's currently booting the whatever the system provides. So let me just fix that really quick.
Oh yeah, we didn't change the networking configuration.
Yeah, exactly. Currently it's trying to layer 3 boot, and that's of course not that useful. I'm just not getting the can't click on it yet.
Yeah, I don't think it may not phone home correctly, so you might want to just spin up a node 3.
yeah, that's probably a good idea. Let's do that. In that case, do I have to select some operating system first to boot, or because I can't configure the network right here, right?
What happens if you click on configure IPs? I can't remember, to be honest. Does that allow you, because you can disable the IPv4, but I don't know if we can change the networking configuration.
I think you can disable it, but you can't. I mean, it's probably possible to switch it to PXE boot when it's provisioned, right? In that case, I'll just go ahead and do that. Because like if it's just Debian, and I could just set it to re-images. Well, maybe that will work. I think it worked earlier, but yeah, that's not too big of a deal, I guess. And we will not configure IPv4. And
if we were creating a device via the CLI or over the API, we'd have be able to set that layer 2 on the device creation. But yeah, I'm not sure we actually expose that available over the user interface. Although you can click on node 2 now, so that actually reboot okay.
Yeah, perfect. I just thought perfect. I remember it working earlier as well, so yeah, perfect.
Yeah, so that's probably just stuck in a little loop right now where it's phoned home, but there's actually no operating system on the device. So now you can switch it to layer 2 moding. And okay.
Exactly. So I'll be switching to layer 2 mode. Again, this is the whole reason why we set up the DNS mask server earlier, because otherwise you would not be able, or the device would not be able to access the internet afterwards. After all. So yeah, that's the little trick we'll be doing. And after that, of course, we have to reboot the machine, and hopefully it will work then.
Yep. Makes sense.
Okay, so here we go. Let's reboot it.
And because we have you enabled the checkbox for Pixie Boot every time, this is going to come through Bofied this time.
Exactly. So yeah, it's still running over here. I should probably be disconnected from the console shortly. And yeah, everything seems to be going fine over here. Of course, no leases yet because it hasn't booted. But yeah, here we go. So yeah.
So let's assume we weren't doing a netboot XYZ here, and we were dragging, like I say, a Talos image into our webdev directory.
Yeah.
I mean, just configuring the iPixie script. I mean, that's all pretty standard. There's nothing unique to Bofied there. It's okay.
It's all pretty standard. I have played around a lot with the 50 DNS server to support pretty much the standard configuration or whatever TFTP, for example, does. So, for example, next server is available as a variable, and yeah, it's just plain TFTP. And you can also use HTTPS to completely securely boot it, which is pretty nice. It will also be possible to of course load the resources using TFTP. This is just a basic setup. Yeah. No Bofied specifics there. Yeah, let's see if it's doing if it's getting a IP address. I hope so. I hope. Let's. Oh, I forgot to add the VLAN. Of course. Okay, one more time.
The live demo curse.
Yeah.
But at least you know what the problem was, and you can do another reboot and fix that.
Yeah. It shouldn't take too long. And
no, like I think because you picked a small instance, these reboots have been pretty quick.
Yeah.
Too much here.
So again, if it's not configured correctly, or if it's using if it's not layer 2, it will always chainload this file or try to chainload this file, which will of course fail. So that's a good way to debug if it's not working.
Yep. And the out-of-band console is invaluable for this. Like
yeah, without this console, it would be completely blind. Wouldn't be able to know.
You'd just be sitting there waiting, going, "Is it working? I don't know."
Yeah. So here we go. It's not trying to.
A good thing people should know, I think, about this is that take a note of that root password, which is only available for 24 hours after machine boots, because I don't think you won't be able to get onto the device with the rebooting into single user mode and doing a whole bunch of hacky things to get back on.
Yeah, there's even a rescue as available. I saw. So in theory, if one were to, for example, try to rescue data, it would even be possible using that. Yeah.
So you can do it out of band, reboot, and then catch the bootloader to put it into single user and reset the password, or you can reboot into the Alpine OS rescue mode and mount the file system and change the root password that way. I have videos on all of these approaches. That was really fun to sit down and do one after them.
Yeah.
It's a lot of hassle. It can be a lot of hassle. Hopefully, you don't need to do it frequently. Oh, we have events.
Yeah, we get the first information. So if we check over here, we see we got the HTTP packets sent to the client. I'm not sure. There might be a problem or misconfiguration on the DNS mask part. I'll be checking that shortly. But as you can see, it's already getting the DHCP packets over here. It's not getting a DNS mask thing. Let me just double check if I've set up the IP correctly. It is .1. Okay. So the issue is obvious. Over here, I set a different IP. It's .1, and I've set DNS mask to only listen on .3. So I'll just change that for a second and restart DNS mask. Let's hope it's quick enough to still catch it. Otherwise, it will just be a little bit of time before it starts. Because again, I mentioned earlier that it's quite useful to just use this panel on the left over here as a way to debug the network. And as you can see, it just was pretty helpful in this case because we know that it already tried to make a DHCP request, but it didn't resolve. It just sent out the DHCP discovers all the time. And yeah, that's probably a pretty nice feature of it. So yeah, let's see if it's doing something. If I remember correctly, I might actually have to reboot the server after this, but it should boot. It should prompt me to press enter again, and then it should work definitely. Of course, all of this is stuff that we will normally only set up once and never touch again. So yeah.
Yeah, if all of this could be automated as well, using user data to automatically provision a device to install DNS mask and configure it. You could do this with Terraform or Pulumi or even just our CLI directly.
Yeah. Of course, this is a very manual way to do it. I just thought if
but it's
professional.
Like I think it's good for people that are watching to be able to see you go through those steps, and the guest will be available in the show notes and such. So all the commands will be there. But don't do it this way in production. You should.
That's for sure. So let's see if it's working. We've set up the link, and now it's been rebooting, and shortly after it should request. Yeah, so there we go. Press enter, and it should now try it again. So it won't be stuck in a loop this time around, hopefully. And yeah, there we go. So we can see DNS mask has has added a IP address, and over here on the left side. And again, these logs are also available using Docker if one wants to use a normal, quote unquote, normal or more standard way to export the metrics or the logs, for example. And shortly, hopefully. Is it still doing something? Yes. It got an IP address, and what it should be doing now is chain loading iPXE, although I'm not sure if it's doing it. There we go. It worked.
There we go. Yeah.
So as you can see, it loaded it using TFTP. It's a BIOS system, so in this case, it's very simple. And we can also see, So and we can also see it handled proxy DHCP for the client over here. Plus, it sent the iPXE file, and here we go. We are logged into netboot.xyz, and because we were able to chain load netboot.xyz, we also know that the internet connection is working, or that this device is able to reach the public internet. And in this case, for example, we can just let's select some live CD to make it easier. And why don't we put Debian?
Let's put Arch. Come on.
Let's put Arch. Okay, so yeah, why not? Let's see.
I've been trying to make it easier to run Arch Linux on Equinix Metal for months and months and months, and now I have my answer. So.
Exactly. So in this case, we can see netboot.xyz is of course doing all the heavy lifting from this point onwards. But in this case, we will of course have also been able to select our own kernel or own operating system. One thing that I, for example, use Bofied to test out is to use Serenity OS or Redux or one of the newer systems written in Rust, for example. And of course, cloud providers, for good reasons, don't have those as a default image available. And if one wants to easily to try these out, it's also possible using this. And one of the nice features, again, about the whole web dev synchronization thing is, for example, if one were to, for example, develop on an OS, one would have to test it on a remote server or something. They could just basically say, okay, whatever artifact is going to be built, say the UEFI binary, they can just push this to the web dev directory, which is mounted on Bofied's part, and they can just have got a really nice compile, press reboot, and then try the OS user experience, I guess. And yeah. So
have you ever booted Redux using netboot.xyz?
Actually, no. I have booted my own little UEFI binary, which I built using Zig. So I guess it should work using Redux as well. I just use it as an example because, but yeah, I mean, anything that is a UEFI binary should be bootable using this system. And even if it's not a UEFI binary, for example, I mean, iPXE over here isn't a UEFI binary either. It would also be doable. Yeah.
That's pretty cool. I like that.
All right, so I'm not sure if it's going to actually channel boot.
Well, this may take a bit of time, right? So.
Yeah, this will probably take a bit of time. But again, from this point forward, it is basically as though one would have the server in their local network. So it should be just basically So from this point onward, I guess it should be pretty obvious what the next step would be. Again, of course, manual OS installers probably not recommend to do that in production, but using something like a preseed file or a proper container-focused distro would be a way to do this.
Yeah, you're also now in a position where you can use the tools that you're familiar with, such as Packer, to build these images with the operating system and the packages that you need on it, and then distribute them via Bofied, and then just pixie boot right into them without having to actually have the out-of-band console available and just hopefully trust that automation. And I think that's a really powerful way to move a little bit quicker with custom operating systems, or even just more bespoke ones.
Yeah. And now that we set it up, I mean, the next boot is going to be really, really simple, because adding a new node to this quote-unquote cluster, or at least to the VLAN, would be just to create a new node, set it to Pixie boot, and that would be everything. It would boot the entire configuration would be on Bofied's part. So it's now that it's set up once, it should be very, very easy to get started. Yeah.
Awesome. Well, that's us approaching the hour. We don't need to wait for Arch Linux to install on this device. I think that's definitely something that I will be playing with. And I'm a big fan of Kubernetes focused operating systems like Talos and Packcar, and being able to have a management interface to work with these operating systems is a really cool technique. And there will be more content coming where I explore using Packard to build images and deliver them this way as well. And I really want to do some hacking on Tinkerbell with Bofied and get these working harmoniously together, because there's gRPC everywhere. I don't think this will be terribly difficult to do. So lots of cool things. Really, really impressed. That was a really awesome demo. Thank you for walking us through that.
Thank you for having me.
All right.
It was a pleasure.
I think we've got the link to the repository. I'll flash that back up. I don't think we have any questions right now. We do have Kevin firing up a VM to play with this. So, that's very, very cool to see.
And if anyone has any questions, there's also a link to a Matrix channel in the project repository. So I'll be there in case anyone needs to have any help. Yeah,
you're very cutting edge, aren't you? Right? gRPC, you've got WASM, you've got Matrix channels.
Yeah,
with all the cool technologies.
I'm just about to learn Rust, so it's going to be even more bleeding edge. But yeah,
awesome. I am a huge fan of Rust, so I'll be following that for sure. All right, Felix, thank you again. It was an absolute pleasure to have you. Really, really cool technology, and I hope a lot of people get a lot of value from it.
Thank you very much.
All right, have a wonderful day, and I'll speak to you again soon.
Bye. Bye.